I'm just messing with some stuff here. What? Rename iPad view. Okay. Cam main. I don't know what that is. I'm gonna remove it. I don't know what that is. I'm gonna remove it. So we need that. Yeah, those are all the important ones. And what is that? That's just that? Yeah. Okay. I think the same for MathLab. Yeah, it should be. MathLab dot online. Yeah. Okay. Hang on, wait. Hey, Carrington. Alright. Sorry I'm late. Oh, yeah, no, I'm still doing it. I was setting up the live stream. Remember I told you I was doing that? Yeah, so that's what I was setting up. I don't know. Oh, hang on, my camera's on. She probably is not because she's in London right now. Yeah, I know. She's going to London and then to Paris and then to Florida. She's gonna be there for senior night. I don't know if you heard that or not. For football. Yeah. Yeah, transformations. Transformations are like the worst.
And she finally started using Vernia's packet for
That's
like
fun.
practice stuff, which is good because it's pretty helpful.
So do you
But
want to
like,
share your screen or do you want me to share your screen? Or do you want to share your screen?
I don't have. I have it on paper, so I could send you pictures of the
Ooh. Yeah, send me pictures of it.
worksheet. Okay, I'll do that. I think this is the one we can use. I don't. Okay, I'll send a picture of this.
Oh my gosh. I only have 6% battery. That's not good.
Yeah, I know. I have to charge mine too. I didn't realize when you said. And oh my God, she gives us these quizzes, but they're not quizzes because we can't redo them. But they're assessments. It's so annoying. She's like, so on Wednesday you'll have like a little like check, and we were like, what does that mean? And she was like, well, it's like, she's like, it's not a quiz. I'm like, okay, well, what differentiates it from a quiz? And she's like, you can't retake it. So it's basically worse than a quiz.
That's funny. It's a mini quiz.
It's terrible because we don't get to retake it, and it's like, it's individual, and we have like no grades in our grade book.
Oh, so it's high stakes.
Yeah, so I have to do good.
Well, let's do
Not
it then.
fun.
Let's talk about it.
Okay, well, and then I don't know. I think she's just talking about this so far, but she gave me like the whole. I just need to memorize all the parent functions, but she has some wacky parent functions she gave us, so I'm gonna make flashcards of them
Okay, well,
and
I imagine
study
they're the
them.
same ones that I did, just like maybe a little
They
different.
are, but she added some weird ones.
Yeah, no, there are some weird ones that I didn't include. That's for sure.
So I was like, but I just need to remember all the like facts about each of them.
Or just remember the shapes. And remember, you can always figure them out. You can always, like, plug in points and think about what the shapes of them would be. So if you
Yeah.
don't remember what it looks like, that's also an option.
Yeah, she has these cute flashcards I bought, or I didn't buy, but I stole them from her. So
With all the parent function graphs on them?
no, I have to make them.
Oh, okay.
She gave us our packet back, so I just have to write all of them.
Yeah, I left a bunch of flashcards, so she should have a lot of flashcards.
Are they these?
I don't know. They're just normal flashcards, so if they're special, then probably not. No.
These are special. Can't forget to do that. Okay, so the first one, let's go back to it.
Okay, I need one more second.
Oh.
All right, I should be ready. Are you there?
Yeah, I'm here.
Okay.
Sorry.
Sorry,
Okay, so
I'm looking for the window. I can't find you. That's weird. Okay. Anyway. All right. So what are we doing?
Well, we can just do each of them. I think it just gets more challenging for me when it's like multiple of like it has horizontal dilation, vertical transit, like a multiple of them. But we can like start with the easier one. So the first one is f of x equals square root of 3x minus 3. So I know that it's square root of x is the parent function.
Mm-hmm.
So should I graph the parent function?
You can graph the parent function. Do you want to make a different graph for every different transformation?
Sure. So the square root of x is like, it's just like a line, like a curve, right?
Yeah. Do you want to do it by specific points? Because that can help
sometimes. I think we have to, because in class she makes us do like, we write the x and the y, and then we do like what they could be points, and then what would happen if they're like for each of the different things.
That is pretty helpful, honestly.
But that's the thing that confuses me sometimes, because like I have trouble. Wait, also you put the square root not covering the 3.
Oh, it's the square root of the whole thing. Okay.
So she makes us do like the x, the y, and so it would be for x. So like, isn't it? And it doesn't matter. Like as long as it works with the square root. So like, I do x's. I can do 0, 0, 1, 1, 2, or 2 is, or I'll do 4. Should I do 4?
So you want to do 4. Yeah, and then
4
and then 2.
2, and then 9, 3.
Yeah, how many points do you need?
I don't know. I just did that.
All right, I think 3 is good.
Okay.
I think just stick with 3 because you'll see the shape with, as long as you choose like a good 3 points, 3 points that like show the whole thing.
And then she says, I'm trying to draw the. Okay, and then now I have to take, so the negative 3. Would I do the negative 3 first or the 3? Does it matter?
It does matter. I almost have to remind myself real quick what it would be. You have to add or subtract first.
Okay.
Hold on, you can't see my iPad screen, right? It just like died.
Oh no, I can't. I can see your graph.
Okay, it's just frozen though then. Hang on. Hang on.
Okay, so if it's -3 when it's inside, when it's inside the thing, and you would consider that directly connected to x.
Right,
So
because
then
it's all
that's a
inside of the
horizontal.
function. It's all inside of the square root.
So that's a horizontal shift, and since it's plus, or since it's negative, that means it's going to the positive side.
Right. And so when you're thinking about with the points, that's what's kind of nice when you think about with the points, you can just add 3 to all of the x values.
So 3,
So I even like to do tables.
4,
You can't see my iPad screen.
7, and 12. So that's adding 3 to the y, or to the x. Wait, do I add it to the x or the y?
To the x, because it's horizontal.
Oh,
Because
okay,
anything
yeah.
side to side, anything inside the function is always done directly to the x.
But then what about then I have 3x. So
Right,
this
so
is the
that
thing
means...
that really annoys me because I don't understand how I do it.
Well, so you're just... To do the operation, so make tables. I think that's probably the easiest way
That's
to
what
see
I'm
it.
doing.
Okay. I'm trying to get my iPad back on. I don't know why my screen sharing's not working. That's really frustrating. Let's try this. Okay. Can you see that? Can you see my camera screen? Like looking at my camera screen, can you see my iPad?
Yeah, I can see the graph.
Okay. All right, cool. So, yeah, so make tables, I think, with every graph. So we have here that when x is 0, y is 0, x is 1, y is 1, x is 4, y is 2, right?
Yeah.
And then the next graph, so you did the -3 next.
Mhm.
And so start there with the table and just say, so you know it's opposite, right? That's why you went to the right. But that just means you're just adding 3 to all of the x values. So like 0 plus 3 is 3, 1 plus 3 is 4, 4 plus 3 is 7. Right? And then all of the y values just don't change.
Yeah. So then now I have this 3 times x. So that means, so is it anything that's multiplied directly to x that makes it like horizontal dilation?
Right, that makes it horizontal because it's inside the function being done directly to the x.
Directly to the x. So then, and I differentiate it by if it's greater than or less than 1? Or less than...
Well, I mean, that's going to tell you if it stretches it or compresses it. But if
Mhm.
you're working with the table, you don't even have to think about that. You just have to say, well, here we're multiplying by 3. And so since x is always opposite, that means we're dividing all of the x values by 3. So you just got to take all these x values that you made and just divide them all by 3.
All the ones I just made.
Yeah, because it's just step by step. So you did the first, like you started with your original points. You did the first transformation. So that got you these points. And then you're going to do the last transformation. and that'll get you the new points. And
So
it'd be good
if
to
it
graph
were
it
to-
every step too, so you can see what it'll look like.
So that means it's a compression.
Right. So it'll end up being.
What
a
if it was
compression.
negative? What was it? What if it was like negative 3x?
You would divide by -3.
You would divide by.
And so that would end up reflecting it. But what's nice about this is like you don't have to
Mhm.
memorize that then. You can just like now that we have these points, I'm just going to plot these points. I'm not going to think about any transformations now. I'm just going to plot those points and that'll let you see what it did. You can see then that it compressed it.
Okay, wait. I'm gonna try to plot it. So, and now I have all my new points, right?
Right. And so these points are just your transformed function.
So I have my x and my y. So my x is 3, 1, 2, 3, and oh wait, I did that wrong. Wait, it's 1, 1, 0. Wait, how come yours is? Oh no, that's right. 1, 0, 4 thirds, so 1 third, and 1 7 thirds.
Hi.
Hey, Rose.
Oh, are we not on Discord anymore?
No, we're going to stay here, I think.
Okay.
Yeah. The MathLab.online does bring us here, right? Yeah. That's how you got here.
Yes. Okay, I was just in the Discord for a while,
Oh.
waiting.
Okay, sorry.
But, oh no, it's okay.
Yeah, this is just easier. We're just all used to this. So,
Okay.
at least for now, this is what we're going to start with.
All right. Are you still streaming, though?
I am on YouTube. I thought I was on TikTok Live, but something went wrong.
Hi, Carrington.
Hi.
We're
Okay,
doing
I got it.
transformations.
That's fun.
So, at least for now, this is what we're
Did he log off?
No, I'm still here. You can still
Oh.
see me, right? Sorry.
I was like, where did you go?
I'm still here.
Okay.
I'm just setting this back.
Okay, the next one, or we'll do a more difficult one. Let's do the f of x equals x plus 1 cubed minus 1.
That's more difficult?
Well, more difficult than the other one that it was going to be. X cubed
that what
plus
you said?
1. Yes.
Okay.
We gotta start easy.
Okay. No, that's good. Okay.
Okay.
So do you want to make the tables again? I think the tables will be good for you.
Okay. So
So start off with the parent.
it's x cubed. So that
Yeah.
means it's like this, it goes like right
Yeah.
like that. Okay. And then okay, so I need to draw my table.
So what are the
Okay.
starting points you're gonna use?
Okay, so I can start just 0, 0, 1, 1, 2, 8.
But you need some on both sides of 0.
What do you mean?
Like you need a positive and
Oh,
a negative.
positive
Like
and
generally,
negative.
you should always use -1,
Forgot about
0,
that.
and 1. The only reason the
Okay.
square root wasn't like that was because you
It's
couldn't
only
plug in
positive.
negatives. It's only positives.
Okay, so I do -1, which is gonna be -1.
Mm-hmm.
Do I do more than -1, or just it's fine
No,
if I do?
I think
negative?
3 points are good. I think 3
Okay,
points.
-1, 0, and just 1.
Yeah.
Okay, so then I have a +1 inside. Do I do the inside first? Yeah.
So this
parentheses
is the order you should do them in, right here. So the shifts on the x, so the stuff that's just added or subtracted to the x, that's what you should always start
Mhm.
with. And then you should do whatever reflections and stretches and compressions next.
Okay.
And then do the stretches and compressions on the y, and then the shifts on the y. That's the order you should do everything in. notice how the shifts are on the outside? It's like a shift sandwich. But then the x's are together and the y's are together. That's kind of how I remember it.
So now it's +1. So that's a horizontal shift. So that means it's affecting the x.
Right, it's inside, it's affecting the x, yeah.
So then it's going to be, if I add 1, or wait, does it make it negative?
Right, it's always opposite when it's to the x.
Okay. Is it always just when it's in parentheses, it's opposite?
Well, it's when it's a horizontal thing, it's opposite. So right, when it's inside of the function. So like here it was inside of the square root function. Here
So
it's inside of the cubed function.
Okay, so -1. So then that's -2, -1, and 0.
Yep, it's just subtracting 1 from all of those and then doing nothing to the y values.
And then you have a -1 on the outside, which is a vertical on the outside. Vertical translation.
Just a shift.
So wait, is this the one that like it doesn't change when it's negative or positive?
Right, because it's on the outside. So the outside doesn't change. So this is just -1. We're just going to subtract 1 from all the y values.
From y. Okay, so then that's -2. Same thing as the other one. Right?
Yeah.
-2. Okay. So now graphing it, I have to go with x, y. So it's -2 and -2. -1, -1. Oh wait, shit. -2. Zeros. Wait, how is that supposed to tell me what it looks like? I only have 3 points.
Well, because you know the shape. Because you know the shape of x cubed. And you know that this middle point right here is still your middle point right here. And so you know it's that exact shape. It just has to go through those points now.
And if I wanted to, I could add more points.
Right, and if you wanted to be more specific, you could put more points on the end. Like, yeah, if you just graphed the next point, it would be like 2,8, so that would be like somewhere up here and down here. And that would show you even better what the shape of the graph looks like.
Okay.
And so if you do that, you don't even need to know the shapes of the graphs.
Now we're going to do a hard one.
All right.
Okay. 2 parentheses x plus 1 close parentheses squared minus 3.
Okay.
So the parent function is x squared. Okay, so I can draw a parent.
So what points are you going to use?
Okay, well, there's 3 things happening. Okay, so x and y. So it's squared, so I don't have to make it negative because it's x squared.
Well, no, you always got to do negatives. If you can plug in a negative, you've got to, because it's not going to show you the shape if you don't do a negative. That's the problem. So if you don't do negatives, you're just going to be looking at this, and that's not going to show you the shape of the graph.
Oh, okay. So I do negatives.
You just got to do enough points. You got to do enough points to show you the shape of the graph.
Okay.
So that's what you got to do.
So I'll do -1, or it would be +1.
Yeah, when you plug in -1, you'll get out +1.
And then 0, 0, 1, 1, 2, 4. And then I'll just do 3 and 9. Okay.
You should do it symmetric though, shouldn't you? Don't you think?
Still more negatives.
Well, because look, otherwise you'll be like, this is what my
Oh.
graph looks like, and that doesn't like show you very nice.
Okay. So then do another negative. So do -2, which is going to be a +4. Okay.
All right. So now, what order do we start with?
Okay, so we're starting parentheses. Right?
Yeah.
So you start in the parentheses, and it's a +1 in the parentheses, which is a horizontal shift. Okay. So that's a horizontal shift, and it's +1, which means it's -1. So I'm doing that to the x. So we're doing a -1 for the x, which makes it -3, -2, -1, 0, and 1.
Mm-hmm. And the rest of them just stay the same.
And then the next thing I have to do is what's multiplying to it, so the 2.
Right. Well, so the next thing would be multiplying by the x, but there is nothing multiplied by the x. So then the next thing is multiplied by the y, right, which is the 2.
So that's wait. Oh, it's the dilation. It's the same thing, right? Or no, is it not?
Well, what are you going to do to the y values? That's all that really matters.
You're dividing it?
Well, it's outside, so it's not opposite. It's just normal.
What do you mean?
It's outside of the
thought it
function. It's
was
not inside. It's not being squared.
Oh,
Just like the -3. That's what we said.
so what is it?
It's only opposite when it's inside. That's why we did the -1 on the x values, because it was inside. If there was a number right here, then we'd be dividing by 2, because that's on the inside. But if it's on the outside, it's just normal. So we're just multiplying by 2.
Oh, really? Why don't I have that written down?
I don't know. That's what we just said. Everything on the outside is normal. Inside is when it's opposite.
Okay, wait. I just haven't done one of those before. Okay, so multiplying just the y or the x by 2?
Well, it's outside. It's outside of the function.
So y.
So the y. Because everything that's outside of the function is doing to the y values. Everything that's inside the function is being done to the x values. So we're just going to copy down our x values. And our y values.
So the y, if it's multiplied by 2, it's 8, 2, 0, 2, and 8.
Yeah.
So that's the y, and then we have another thing on the outside, which is a -3.
Mm-hmm.
So that's also applying to the y,
Mm-hmm.
and it's just going to be -3.
So we're just going to subtract 3 from all the y values. Exactly.
So -3 from 8 is minus 5. No, 5, just 5.
Yeah.
5 minus 3, 1, -1.
Mm-hmm.
And then -3, -1 again, and 5 again. Okay, so now I take the x's and the y's. So, okay, sorry. Okay, so the next thing is I graph it all.
Mm-hmm.
So, wait, was that a 3 for the top one?
Where?
One second.
Okay. Rose, what are you working on?
I'm working on a game that we have like one of those quizzes games, for calc, just preparing for the quiz
Oh, like
tomorrow.
the bingos?
So yeah,
Okay.
I don't know if it's bingo, but it's this website called Quizzes. Like
Oh,
it's
okay.
cool, but uh, but I'm trying to write the equation of a tangent line. So when you're writing the equation of a tangent line, do you find first the equation of the regular line at like the
Well, you mean
or
like the
no?
derivative?
Yeah,
Yeah, because you need two things. You need a slope and you need the point, right?
right.
Anytime to write
Okay.
the equation of the line. So you got the point wherever they're asking you to find the tangent line at, and
Mhm.
then you got to find the slope at that point. So that means you got to take the derivative and then plug in whatever x value you're looking at.
Okay. Yeah, that makes sense. So I'm just gonna continue working on it. If I have any
Okay.
questions, I'll be sure to ask.
Yeah, you can interrupt us too, especially if it's a quick one.
Okay, I'm graphing it right now. Um, 0, 0, -1. Wait, how does that make sense?
Well, you can graph all the points and you should see it.
That's what
Hopefully.
I'm doing. Yeah, but then I got there and it's 0 and -1. That makes
Yeah.
sense? Hmm.
Doesn't it? Doesn't the
Yeah.
shape sort of look the same as it when it started?
Oh, I guess. I don't know. I just thought it looked. Okay, wait. Then I have 1, 5. I mean, yeah, it's a problem.
Yeah, it's a parabola. And see how it's just taller and skinnier.
Yeah.
But it's still a parabola. So it's taller. So it's stretched. It had a vertical stretch. That was the 2 on the outside.
Mhm.
And then it's 1 to the left because that's the +1 on the inside. And then it's 3 down because that's the -3 on the outside.
Okay, I have one more.
Let's hear it.
The f of x equals cube root of 2x plus 2 in the cube root, and then a +1 on the outside.
That's a good one. We haven't done any reflections.
Is
Our
this a
reflections are
reflection?
just no, it's not a reflection. Just saying we haven't done any reflections. But our reflections are exactly the same. You just do it like
How do
you
I?
multiply or divide by a negative. It'd be exactly the same. Like if this was a -2, then that would be a reflection. And the only difference would be instead of dividing by 2, you'd gonna divide by -2.
Oh,
That's the only thing that's different with it. And then you'll just see the reflection on the graph. That'll just make the graph turn around when you do that.
okay. So this one. Do you want to turn this into a negative?
No, we don't need to. We can just do it how it is.
Okay. So first thing I do is, well, I know the parent function, isn't it like this, where it's like a snake?
Yeah, except for it doesn't get flat in the middle. It gets vertical in the middle. It goes like that.
Oh, what was the other one?
X cubed. See how
Yeah.
these are related? These are like flipped of each other. This is x cubed. This is the cube root of x.
Okay, got it. That's what I was imagining, but okay. So I know what the parent function looks like. Now I have so we first do would I do the +2 first?
Yeah, +2 first. Start with what's added to the x.
Okay. So x and y. Okay, so I'll just graph the other ones. And since it's going on the negative, I'll do a -2, which makes it, cube roots.
Yeah, so -2 is not going to be good.
Okay, so -3, which then is -1.
Cube root of 3 is 1. 1 times 1 times 1 equals 3.
Oh, wait. cube root of -9.
What's the cube root of 9?
Oh shoot, I don't know cube root.
Well, just take a small number. So 1 times 1 times 1 is 1, so you can do the cube root of 1. But what's 2 times 2 times 2?
8.
8.
So -8.
So -8.
-8 and -2. -1, -1, 0, 0. And then same thing, 1, 1, 2, and 8. Right?
Yeah. We need more room.
Okay. So now I'm doing a +2, which means it's a -2 for the x, which is a horizontal shift. So that's -2, so that's -10, -3, -2, -1, and 6. Okay, and then I do the multiplication, and since this is 2 times 3, then it's 1/2. And that's horizontal dilation, which is so that's 1/2. And this is affecting the y as well, right? Because it's inside.
Well, it's inside, so it's affecting the x, you mean, right? Affecting the x as well. Yeah.
And then, so then I do that, so that's -5, -1/2, or 1.5.
Yeah. I would say 1/2.
-1, -0.5, and 3. And then the last thing is going to affect the y, and it's a +1, so I just +1 to everything. So that's -1, 0, 1, 2, 3.
That should do it.
Okay, so let me see. -5 and -1, -1, 0, -1, and 0,
Looks pretty good.
and 3, and 3. Does mine look right? Can you see me?
Yeah, I can see it. Yeah, that looks okay. It's hard without graph paper. You really need graph paper to
Yeah.
do these properly.
I'm kind of making up what I can. So if that was a negative, it would just be the opposite way, right?
Right. It would end up just being the opposite way. And the only thing you would do different is instead of dividing by 2, you would divide by -2. Or if the negative was on the outside, you would just be multiplying everything by a negative.
Well, thank you. I think that definitely helped.
That's it?
And I will
Okay, good.
definitely be back tomorrow.
Okay, good. When's the quiz?
It's on Wednesday.
Okay, excited. So remember this order. And if you take the time to make out these tables every time, I think it's pretty foolproof. And then you just remember the inside is always the x, the outside is always the y. The inside is always opposite, both with the addition and subtraction and the multiplication and division.
Multiplication, opposite. Oh yeah, it's divided.
Right. And then if you had, if this was a 0.5?
Mm-hmm.
Or maybe just come down to this example here, so it's like the same. If this was a 0.5 instead of a 2, you don't have to do anything differently. You just divide by 0.5.
Why would it be different if it was a 2?
Well, I'm saying here, when it was a 2, we divided by 2. When it's a 0.5, we just divide by 0.5.
So I would divide everything of the x values by 0.5.
Right. the kind of question is, what does it mean when you divide something by 0.5? Well, what is
I don't know.
0.5 as a fraction?
1/2.
1/2. And what happens when you divide by a fraction?
Keep, change, flip.
Keep, change, flip. So you're multiplying by 2.
Oh.
So 3 divided by a half is 6. Because when you divide by a half, dividing by a half is just multiplying by 2.
See, she did that and I was so confused. Okay, that makes sense.
Yeah.
So I do that to every x value.
Right. You would just do that to every x value. Just like we just divided 2 to every x value.
God.
So like in that case, it wouldn't be dilation. So that's her like bigger than 1, smaller than 1 kind of idea. Like since this is smaller than 1, it would end up being a stretch. But you don't have to worry about that if you're just dividing by 0.5, because that'll just work itself out in the points. And then you'll see that it's a stretch.
Oh. That makes sense.
Like if you're doing this with every single point, you really don't have to think about like, is this a horizontal stretch? Is this a vertical compression? Like whatever you want to call them. You just know, like I'm subtracting 2 to the x's. I'm dividing 2 to the x's. I'm subtracting 1 to the y's. And you're good to go.
Okay. Thank you.
All right, no problem. I will see you tomorrow with more questions.
See you tomorrow. Bye.
Bye. All right, Rose, how's it going?
Okay. All right. So, I'm just gonna share first before I finish the quiz. I decided I was gonna do the note sheet because that way I can like reinforce what I know already before I take the quiz, or not quiz, the
Quizzes.
whatever it's called, the game. Yeah, quizzes. So for this one, what is the difference quotient? What's the difference between the difference quotient for IROC and AROC?
These teachers use all these acronyms. I don't know what AROC or
Well,
IROC is.
the IROC is
Oh, okay,
the
yeah,
IROC
yeah.
is the instantaneous rate of change, and then the AROC is the average.
Right,
But
okay. The difference
wasn't sure.
quotient.
I wasn't sure if this was correct or if this is actually the difference quotient.
Yeah, I think that's... Yeah, I feel like they're just the same, except for one of them has h approaching 0.
Right. I feel like then, I don't know if I was supposed to do the one that's like the f of x minus f of a over x minus a for AROC, because it says here that like this is the average rate of change, and then this whole thing is the instantaneous rate of change. So I wasn't
Yeah.
sure.
That makes sense, because the instantaneous rate of change is what happens as the points get closer together and the
limit.
average rate of change.
Right. Okay. So then here I would have to get rid of this limit and just leave it like that, right?
I mean, I don't know. I'm not sure.
I think so, I guess. Or I can write it like this. Well, no, that's actually a better way. I don't know. I'm pretty sure this is right.
I don't even really know what a
And then
difference
here-
quotient is, to be honest.
I know. I think it's just this. Okay. I mean, at least here I give both ways of finding it. And then why is the limit needed to be able to find the IROC? Is that just because that signifies that it's the instantaneous rate of change? Or because the lines of the points of the secant line need to get closer and closer together
Yeah, that's what
form
that's
the
a better
tangent
answer.
line?
Yeah, that's a good answer.
Okay.
Okay.
Okay. And then, wait, did I just do this wrong? No, I don't think so, actually. The definition of the derivative form. Isn't this just the derivative form?
Well, you got those two that we talked about last
Right
night. You
here.
got that. Yeah, those two that you just wrote. Yeah.
Yeah. So this is just, so is that the difference quotient then? I have no idea. I think they're just one and the same.
Yeah, I suppose so.
Wait, this is the definition. Oops, so it should be words. So I would just say this one. Hopefully that's readable. And then
Wait, I don't think that's what we're talking about here.
also-
I think she wants you to describe what's happening in both of these definitions.
Which
Like about how one,
definition?
the two different derivative definitions, about how one of them, the difference between the points is going to 0, and in the other one, the points themselves are coming together. Like the one point is becoming the other point, whereas on the other one, the difference between the 2 points is going to 0.
Oh, okay. Okay, that makes sense. Okay, so for the limit, the distance between the 2 points is approaching 0.
Yeah. This really all just feels like busy work. This doesn't even feel like calculus.
Well, it's helpful for when we're studying, but I think that like it's helpful to go over to reinforce what I already know. So but otherwise I think it is sort of busy-ish. So this is the specific point. Wait,
Well, see
would
how
it
the
be
x is
like
becoming
x?
the a value. So the 2 points are becoming each
Right.
other.
Like, right? I think that's fair.
Yeah, I suppose those are just so similar. I guess people do talk about them
They're
like they're
very
two different
similar.
things, though.
They're very similar, I agree. And then the explanation of the derivative function is this right here. I also like the slope of the tangent line equals derivative.
Say that again.
Oh, never mind. I just
Okay. Oh yeah,
was
slope of the
writing this.
tangent line is the derivative. Yeah. It's a nice, easy to understand definition.
Yeah. And then a diagram with the tangent line. Right? Wouldn't it be like
Yeah, you know what a tangent line
for
is.
this point? No, I know. I was gonna just put it there. Just
Yeah.
trying to draw it.
Yeah, definitely.
Okay, and this is the last one. A part of me is still a bit confused about this part of it.
Okay, hang on. I've lost yours. The share your screen thing is just like gone.
Really?
Yeah.
Do you want me to re-
Yeah.
Okay. Can you see it now?
No. Yeah, things are just not going right.
That's okay. Do you want to stop YouTube?
Maybe. It's just ridiculous. It's like minimized, and I can't see how to get it unminimized.
That's really strange. I mean, I'm technically finished right now, so I did the last one.
Okay, I think I might have just found it, but maybe not. It's like it's hanging off of my screen and I just can't grab it. That's like shocking. Oh, did you just unshare your screen?
Yeah, I just
Oh,
unshared it.
okay.
Here, I'll share it again. Can you see it now?
No, it's the same crazy issue.
That's really strange. It's okay though. I mean, I'm finished sharing my iPad screen.
Yeah, but it's the principle of the matter. I hate being inept.
Don't worry, you're definitely not an F.
Yes, I am, because I could just extend it and extend the area that I could grab. Okay. No, I can totally see it now. It's perfect.
Well,
Okay, what was
now
the
you
thing you
know.
said you weren't sure about?
Okay. The conditions for differentiability. I understand what you need to have for it to be differentiable. But what I don't understand is, well, no, I understand it, but sort of. It's kind of confusing to me. Like, for example, here, number 13.
Mm-hmm.
Are you just supposed to first find the derivative of this and this,
Mm-hmm.
and then set them equal to each other?
Yeah, it's the exact same thing for it being continuous, except for it's with the derivative.
So I
So-
don't find the limit as x approaches 2 from the right side.
Well, you do that as
and then
well,
say,
actually,
like,
because it also
4a
has to be
plus
continuous.
b.
So you have to do that as well.
Okay.
So you have to show that
first
it's
I should do that,
continuous.
you're saying?
Yeah, first you got to show it's continuous.
Okay, so like
So yeah, you need to like plug in 2 for both of them and then set them equal to each other.
right, and then I get
9.
32. Yeah. Okay. So then
So
I
4a
set
plus b
this
equals
equal
9.
to each other.
Right. So we need that. So yeah, we're basically gonna get a system of equations or something like that, and that's gonna be one of them.
Okay, so that's the first. And then, like, I'm just gonna erase this so that I can have a clean slate. And then I do the derivative, so g prime of x
Mm-hmm.
of this function
Well,
first.
both of them. Yeah.
So
you're
if I
gonna-
use the power, well, yeah, this. So if I do that first, if I'm using that, like if I'm not using the power rule and I'm using the other, the limit as h approaches 0
Mhm.
function, how would I do that? Would I just say the limit as h approaches 0 of a times x plus h squared plus b
Mhm. And then
minus
Yep. So you just do it the exact same way. It's
a
just
x squared plus b?
Yep, exact same way. You just got to make sure you do it all right, and then over h.
Okay. Well, I could just do it the power rule way
Yeah, you
for
just
right
do it
now
the power
because
rule
this
way.
is sort of easier. So this is 2ax. Right, because the 1 stays. Plus, and then this is 0. So plus 0. And then the g prime of x again for this would be 16x is 0, so 1 minus 0. So
Yeah.
then I set these two equal to each other. as
Yep.
well. So
Why is it
2ax is
2?
equal to
Oh, yeah,
16.
2ax. Yeah. But then at specifically x equals
Plug
2.
in.
Right, so you're also plugging in x equals 2.
Okay, so then I'd say, wait, I should just keep that up so I can have it. So then I'd say the limit as x approaches 2 of 2ax plus, or 2ax would just be 4a. So then I say 4a is equal to 16. A is equal to 4. And then to find b, I'd just say 4 times 4, or no. Oh, I plug it back in here.
Yeah. So it is 4 times 4.
So then I say, yeah, 4 times 4 plus b equals 9. So 16 plus b equals 9. So that's negative 7. So b is just equal to negative 7 then?
Yeah, should be.
Okay.
Yep. Yes, that's all you gotta do. You just gotta make sure they're continuous. So you plug in and set them equal to each other, and then take the derivative and plug in and set them equal to each other.
Okay, that's not too bad. Oops. That was not a good idea. Do you want to do one more? I know math labs or over. Do you want to?
Yeah, we can do one
leave?
more. We can do one more.
Okay. Sure. So then for this one, I know this isn't possible, but I just want to make sure I understand why it's not possible. Because I get why it's not possible to what. So first I do the limit as x approaches 1 from the right, or excuse me, from the left. So of ax minus 7. So I get a minus 7. And then the limit as x approaches 1 from the right side of 2x plus 3. And I get 5. So I say a minus 7. A is equal to 12. Okay.
Mm-hmm.
And then I do the derivative. So h prime of x is equal to a minus 0. H prime of x is equal to 2 plus 0. Then I set those equal, so a is equal to 2. Oh, but that's different. So then that's why
Right, exactly. And that's why it's not
it's
possible.
not possible.
Yeah.
Because this is the continuous part.
Mm-hmm. So for it to be
And this is
continuous,
the
a
slope.
would have to be 12. And for them to have the same slope, the slope would have to be 2.
So for it, I'm just writing this down so I can have it.
Like I would say you showed that in order for them to be continuous, the slope would have to be 12. But if the slope of the first part is
slope?
12, yeah. Isn't that what a
Wait,
is?
okay.
A is the slope?
Right, yeah. I just
'cause it's a
wasn't
linear
thinking about it
equation.
like that.
Yeah.
Yeah. Okay.
But that's
So-
what the derivative is. Like that's what you did when you took the derivative too. You found the slopes. Right? Because you found the bottom one was 2. Because that's also what the derivative is.
Right.
Is the slope.
Right.
And it's just a line, so that's why the slope is just 2. So it's just like mx plus b.
Okay.
Then the
So
slope of
for
the
it to
first one's a.
be the slope however, like the slope equals 2. The slopes of the derivative equal 2.
Yeah, the slope of the second part of the function, the slope of the right half of the function, is 2.
So it doesn't match.
Right, so it doesn't match.
Okay. So you can't say it does not exist, can you?
Well, there is no a
You just
value that
say-
exists. You could say that there's no a value
Yeah.
that exists for that to be true.
Okay. Well, can you say D and E?
Yeah, because find the value that exists. The a value does not exist.
Yeah.
I guess that's not
true.
like the normal use of D and E.
Wait. Yeah. So
I don't
maybe
know
I
if it
won't
is
do
or not
that. I'll
use.
just say not possible. Okay. Well, those were essentially all my questions right now. But so
All right, so let's hop off of here then.
okay. Thank you.
All right,
Bye, Robert.
no problem.
Bye.
Bye, Robert.
Good job.
All right, thanks. Bye,
Thank
everybody.
you.
If anybody else is here.